Welcome. This is our September edition of the monthly OpenLineage TSC meeting. So as usual, this is recorded and archived on the LFAI and data wiki. I'll post also notes that I'm going to take at the end as well. And let me open my note taking, by the way. And ready. It's precise. So we'll start by doing a quick roll call of who's present. So I can start. So we can do a quick, just a quick intro, and why you're interested in being there. And if you're just here for listening in, this is fine as well. So let's start. So I'll go, I guess, top to bottom and left to right on my screen. So first I see Mandy.
Okay, so I lead the Ageria project, which is an open metadata and governance integration and project. So we're looking to integrate with OpenLineage, which is why I'm
here. Michael.
Hi, yeah, I'm a software engineer at Dbt, working on OpenLineage and Marquez.
Sorry, for some reason, Zoom is not showing me names anymore. Oh, Venkatesh.
Hi, I'm Venkat, presently at BMC. We are an orchestrating tool we have, and I want to see if I can use this metadata framework to build Lineage for that orchestration tool.
Maciej?
Hey, I'm working at Getting Data. We are big data consultancy, and I'm working on OpenLineage monthly integrations.
Willie?
I am Willie. I'm I'm the co-creator and TSC member of WeWork. I'm sorry, wow. It's so early in, I did not mean to say that, of Marquez. And the reason I'm here is I'm just interested in where the OpenLineage project is going, but I'll also be giving a demo today, so that's also exciting.
Nice. You're not tall enough to be a co-creator of WeWork.
No, yeah, that would be the main giveaway.
Minkyu.
Hi, I'm Minkyu, and I'm software developer at Datakin, and I'm here to learn about OpenLineage, and I'm pretty new to open source community, so I'm catching up and learning things. Thank you.
You, Ryan?
Hi, I'm Ryan Blue. I'm from Tabular. We're an Iceberg company. I'm here because I'm very interested in lineage collection across services to help us understand how to basically manage data better for our customers.
And last but not least, Arthur. Or Arthur.
Morning. Hi, I'm Arthur, and I work at Apple on lineage questions for Siri and AI/ML. And so very interested in implementing OpenLineage and Marquez for us.
Nice. So just taking a quick note. Thank you, everyone. So I think we have a good quorum. So Next slide is just a reminder of where communication is happening, right? Like feel free to join the Slack or the mailing list to follow up on the items, and then the notes will be posted on the Foundation Wiki. And of course, usually we also follow up a discussion on GitHub issue on the GitHub project. So today for the agenda, we prepared, but this is the part where we can also add items to the agenda that were not discussed in advance. So we'll do a quick update on the latest release of OpenLineage. And Willie will do a demo of what the Dbt integration looks like. And it got a couple of iterations. You'll notice that last time we talked about the 0.1.0, and we were talking about the scope of 0.2. So the scope of 0.2 moved to 0.3 because we did quickly a 0.2 release to make improvement to the Dbt integration. So it's kind of, and this was too big to be a patch level. And so we did a quicker release. So it's kind of everything got incremented, but that doesn't change much to the timeline. So now the next release will be a 0.3. And as part of this discussion, so there's an ongoing ticket for the Facet versioning mechanism. So basically it's kind of taking the spec and splitting it into individual files so we can keep versioning of the core spec independent from each facet definition. And it also puts all the custom facets on the same equal footing as the core facets. Mandy will go in the details of the proxy backend. So last time she presented her design, and there's an issue. And since then, she's been working on more details on that. So she'll give us an update of where we're at. And one thing we thought also would be interesting to talk about is as part of having another implementer of OpenLineage, it's not just Marquez anymore, to start having test data and validation process to facilitate the life of the implementer when consuming OpenLineage, as well as producing OpenLineage data. So it's more for discussion. I listed the Kafka client, and I think in the roadmap aspect, someone mentioned, and actually let me add Beam. Someone mentioned on the Slack that it would be interesting to talk about the possible Beam integration. Is there anything else people wanted to talk about?
I thought that I was giving an overview of Iceberg and Iceberg potential facets. I thought we talked about maybe doing that the last time, but
that's fine. That's fine. I think we have time to do that. So I'll just add a tag. Yeah, sorry. Yeah, I was looking at the notes. I think last time we talked about this, I was not sure if this was happening. So
oh, no worries.
Yeah, let's do this. I think we have time. I don't think we need to. So I don't know if it's not necessarily in the scope of the next release, but it's like in the near future, right?
Yeah. So I'm not sure when we would add facets for Iceberg tables or things like that. I think for me, it'd be nice to talk about like what we might do, and then what sort of fits with what everyone here actually wants, because I'm not sure. Like, there's the stuff that I want to get back from every Iceberg scan, but is that does that fit with the project, or should we should we work on this ourselves? Like, is this like what a custom facet is? It'd be good to see how everyone sees that fitting into OpenLineage.
Yeah, okay. We'll make sure to have time for this. I think this is fine. Some of those aspects here, I think we can, for some of the topic I put above, we can like just say, hey, we create a ticket and follow up there. We don't need to spend a lot of time on that. So that sounds great. We will make sure to have time for this. Okay, so sorry, before I move on, is there anything else we should be talking about? Okay. Quick update on the latest release of OpenLineage 0.21. So last meeting was before the first release was actually pushed. So now this is all pushed. We have done a couple of iterations to improve on some of the aspects of the initial release. There's a Python client that's available on PyPy, and the Java client is available on Maven. And the next thing we wanted to show a little bit more was the Dbt integration that Maciej worked a lot on and is the main contributor. And Willie had prepared a quick demo on how that looks. So Willie, I'll stop sharing and I'll let you do a quick presentation.
Great, thanks, Julian. Okay, yeah, so like Julian mentioned, the one key focus for the OpenLineage project is to kind of capture lineage metadata on different frameworks, and one of them is Dbt. And yeah, Maciej has been doing amazing work, sort of making the integration super simple, and that's what I wanted to walk everyone through. The one thing with OpenLineage is that you do need a backend to actually send these lineage events. So we'll be using Marquez. So Marquez is a backend implementation of OpenLineage. So it has an API that you can send OpenLineage events. And then on the backend, it stitches those events together and then produces a lineage graph. So the example that I have, it's just gonna be around BigQuery. So I don't, if you haven't used Dbt before, it just allows you to define analytical workflows. So if you do ETL, things like that, transform data, it also stitches together the dependencies. So those types of dependencies is something we do want to capture, because a lot of your workflows aren't just going to be defined in Dbt, they're going to be in Spark and other frameworks as well. So in this example, I'm just going to be using, let me go here. If we go to our models, it's just going to be some SQL. It's not necessarily that this is a key part of the demo, but normally you're going to have models which represent sort of the queries that you execute, and it's stored into a table. And here I just have I do a select star and some orders by day data, which here you can see there's a reference. So it's constantly just referencing other tables, and that's how Dbt, when you run the docs command, or there's a command that you run that generates a static lineage graph. And so it uses these anchors or references within your SQL to generate that. But that's great if it's something that you want it to remain static. But the integration that we have with OpenLineage allows you to have this be more dynamic. So what I mean by that is, if I go and I look at the instructions, all you really have to do is just a pip install and download the library. And then there's a few things that you have to set. So one of them is just going to be the OpenLineage URL, the API key and namespace. The only one that we're going to set is just going to be the Marquez URL. So I have it running in the background. And here you can see that we're able to post to the lineage endpoint. So what I'll do is I'll just run a quick export. Oops. There you go. And then it's going to be localhost and 5,000. Cool. All right, so that's set. So under my Dbt project, normally I would run Dbt run, which goes through the sequence and runs the queries, and it's going to hit some BigQuery tables that I have defined. But when you do the pip install under your bin directory, you get this Dbt OpenLineage wrapper. So that wrapper really is what does the collection of metadata and then sends it to the backend or the OpenLineage backend. So if I do a run here, and maybe before I do that, yeah, you have the awesome. So the one thing that the integration does have is that it can also collect the schema for the tables that you have defined. So there's this catalog.json that can be generated by doing dbt docs generate. So I'm going to run that, and what that ends up doing is it not only captures the input and output tables, but also the schema. So the integration is going to look for that catalog.json file, and if it's there, it's then going to report the columns and the column types. All right, so let's run this. Okay, nice. Okay, nice. Oops. So now I'll run this, and what I'll do is I'll go to the Marquez UI, so you can see it's fresh. There's no metadata there, and then you have the steps that are running. So it's just kind of saying, hey, I'm running this model, running this query, and at the end, after it ran a few, in this case we only had three different models that we were executing, and here you can see that there's 6 events, and that makes sense because first you send an OpenLineage start event and complete event, and now if I refresh, and I'll click on one of these data sets here for that. Cool. So we zoom in. So circles in the lineage graph for Marquez are jobs, and then the squares are data sets. So here you can see that this was a dbt run command on the model. So you can see the namespace, also where the data is coming from in BigQuery, and also the table itself. And then you can see the schema that was executed. So all that's being collected with OpenLineage events, and on the back end, the inputs and outputs are stitched together and maintained by Marquez. So eventually you get to this orders by month, and you can see the schemas here. It wasn't too exciting. It's just that one column. So yeah, if you found this interesting, try it in your dbt project, and I think you'll be pretty amazed to see how complex some of your queries are. And that's all I wanted to show.
Thank you.
Mm-hmm.
And I think one of the nice thing about the dbt integration is, like, because of the way dbt works, it's really easy to try it out locally in dev mode, as opposed to Airflow, which is a little more involved to try the integration because of the way Airflow works. So that was, yeah, go ahead.
I can just add that you can run it in Airflow. Just use bash operator and use dbtol.
Yes, yes.
That's the nice property of this wrapper based integration, that it works everywhere where you just run the dbt binary.
Okay, yeah, I didn't know that. I think I did get some questions in the past, especially around the community meeting for Marquez, around how do we run this in Airflow. So I didn't have an answer on, yeah, good point, Manchit.
That's a good point that we should probably
highlight.
Add this to documentation, right?
Yeah, absolutely.
Yeah, feel free to open a ticket to add that. Cool. So I think next we wanted to talk a little bit of what's coming in the next release. So there's, of course, the Proxy Back-End progress. There's been work going on making sure Spark integration works with 2.4 and 3x branches and improve data source coverage. There's work in progress to make sure it works, the Airflow integration works with Airflow 2.0. And there've been great expectation improvement in progress. But I think the main thing, so those are things that are in progress, and you can check on the project board if you're interested in the status. And the main thing we wanted to talk about is the proxy backend. So I'll let Mandy, do you prefer to share yourself to follow your slides, or okay? So
no, it's fine. Yeah, there's only 3. So what this was what I presented last time to really show the purpose of the proxy backend. So it allows a small local process to be the backend for a job that's running whatever runtime it is. And all it does is it pushes it to Kafka. So that means that there can be multiple consumers for it, but also the consumers don't actually have to be running at the same time as the job, because the Kafka will act as an intermediary store for these. And so that was the initial, and we were going to test this by doing integration with Egeria. And since that time, I've been looking at the internal design of the proxy backend. How flexible do we need? Do we need to be able to support multiple topics? Do we need to be able to support different types of support? And I thought, oh, well, that means we should use Egeria's connector framework and all that sort of thing. And then I realized that actually it would be better if it's kept very simple, so that it's a simple thing that you can keep running at the same time as the engine that's producing it, because it has to be, because it's an HTTP. In order to capture lineage, it has to be running. So keeping it simple makes it much easier operationally to keep it running. And so just focusing on pushing out to Kafka as a first implementation seems to make sense, and then Egeria will pick it up, or any other things, but the initial test case will be Egeria. Now, Egeria has different types of servers. They run on a platform that's highly scalable. So we can take a large number of events coming in, and the server that hosts the connector that understands OpenLineage is called the integration daemon, and that matter's just coming up. So I presented this and a little bit more detail on how Egeria would integrate in this at the Egeria community call last week, and they loved it. They love what you've done, and what I want to show you is the subsequent, sort of the patterns that I showed. So this particular picture is showing, you've got a lockdown or a private processing environment that's running, and this happens quite a lot in companies where the metadata and other types of governance stuff sits outside of the running environment, but Kafka's sitting there and is basically receiving the events, and that's being picked up. So that's the basic using the proxy backend. The next picture shows, that's it, cool. Actually shows Egeria directly implementing, so becoming a backend itself. And that would be the integration daemon. The integration daemon basically supports lists of different types of connectors. And so in the integration daemon, we can add, something that's going to write to a log file, something that will distribute over, 3 or 4 different Kafka topics, taking different selections and things. So we have the ability to fan it out over lots of different destinations, but also to do selection on what actually goes in different places, because some listeners may care about top level processes only, others may want the detail all the way down. So that's the second option. And then the third picture I've got is showing what could be behind it. And it actually doesn't matter whether we're going via the proxy backend to Kafka or whether we come directly into the integration daemon. But we could have a connector that is maintaining a lineage log store. So some processes might have requirements that we keep the lineage for 7 years. Others, it's barely useful for 5 minutes, depending on what type of process it is. So the log store would allow different retention policies to apply to different aspects of the lineage logging. The other thing it does is allows us to do what we call governance by expectations. So in the metadata, we would say, well, we expect this process to run 3 times a day and to produce on average 5 million records or whatever it's doing. And if it goes out of that scope, then we would, sort of detect that and start raising audit logs or audit log events. Now, to do that sort of thing, most of the hardest thing to monitor is something missing. So this job didn't run at all, so there's no lineage. And for that, we need persisted log records, which is why we have the log store there. So that would be one alternative. The other is obviously we would be capturing the processes as metadata, as assets, and they would then link into the Egeria lineage. But we also need to correlate because there'll be other connectors sort of that are cataloging the data sources and other things that they are APIs and things that it's finding. So we have some fun and games correlating unless we have good naming conventions, which happen in some environments and don't happen in others. But then once that's connected together, then it's distributed through what we call our cohorts, which is peer sharing metadata repositories. And so the lineage can go into different processes, which includes this governance stuff. So I hope what you're seeing is that by bringing, the proxy backend gives us flexibility in deployment in terms of availability of the whatever capabilities capturing the metadata. So sorry, the open lineage. Plus also behind the scenes, Egeria can bring a lot of additional value, particularly around distribution of the open lineage content. The only thing to be mindful of is that Egeria is a metadata environment, so it's less caring about instances, which is why the lineage log store actually has the instance information in it. Egeria will talk about a general process implementation and how it would link. That will be in the Egeria lineage, and then the lineage log file. So the open lineage is what we call operational lineage. That is about how well is this process operating according to its definitions. So that's really as far as we've got. Is this making sense to people? Is that division between what belongs in open lineage and what belongs in Egeria, does that make sense to you? Or would you rather have a more sophisticated proxy backend in open lineage?
So so from those two options, so you picked, so did you decide not to have a proxy backend, or do you decide to have both? So
Yeah, both,
okay.
because I can see, because I can see situations where the process environment just really can support just a simple proxy backend. It might be an edge device or whatever, and so you have something that just literally can pump out simple events. It's easy to keep it running in line with the engine. So that's a good example of using the proxy backend. Whereas you might have, you might want to do more sophisticated capture in line, and that's where you would use either Marquez as the direct backend or Egeria as the direct backend.
I think, yeah, that makes a lot of sense to me. Like there are typically two types of users, right? There are the users who want like the simple use case, like you're saying, like, so they just want to be able to point directly to the one thing they're using, the open lineage to the one thing they're using. And then there's a use case where they're either interested of using multiple solutions. They might want to use Egeria and Marquez and something else together. Or they may be interested in building their own solution as well on top of it. And so in that case, the proxy backend, I think, as a distribution mechanism, it makes a lot of sense. So I think, yeah, both, I think like that's aligned with what we're thinking, for example, for Datakin, right? It's kind of like either people want to use directly something and they want a simple setup and they don't want to worry about deploying another daemon, or they want to own their logs, they want to be able to store them themselves or consume them or distribute them to multiple locations in a central place, and then they want it. So I think, yeah, that's definitely aligned with, I think we should start like articulating that in the documentation, right? That the proxy backend exists, we should like document this kind of picture that says, oh, you have the option of owning the distribution, or, you know, like simple, just point to something that implements the endpoint.
Yeah, and do you want that? Shall I can draw the pictures and put the description. I could put it into the issue for this, or is there anywhere? Because that's actually what I was wondering is, where do you want this implementation to go as well when we build the proxy backend?
So I think the proxy backend should go in the OpenLineage repository, if that makes sense to you.
Just a new subdirectory
I would say,
underneath.
yeah.
Okay.
Yeah, I would think so. And it's a generic thing you can deploy. And so as part of this, I would think as part of this PR, we could update the documentation or a separate PR, and we could have markdown files that describe, what the context for proxy back and when do you use it or not use it, right? Like, and I think in the quick start for OpenLineage right now, we show Marquez. We can say, hey, you can do a quick start with Marquez, but then the quick start could have like a menu. Are you like, do you want a simple quick start or do you want a more sophisticated one? And that would describe the two scenarios, right?
Yeah, that's good. That's good. And then we can just bridge to, if you're looking, if you want to do lots of stuff, then this is how you bridge to Egeria.
Exactly.
Yeah, I think that's really nice. The other piece that we're doing is also we do capture operational lineage as we're onboarding the data into the data lake or whatever, and that will be outputting through the to Kafka. So just as if we're behaving like I don't know what you call it, the producer of the events, and that means that Marquez will be able to display the lineage of our simple provisioning jobs that we run. So we'll be able to show two-way integration of through the Kafka topic effectively. So it's almost like it becomes an exchange capability. Do you think Marquez will also be able to receive from the Kafka topic?
I would think so. Yeah. So my next question was, do we want to add to OpenLineage the symmetric of this, right? Because there's the proxy backend that does HTTP to Kafka. Do we want to have some kind of distribution client that can read from that Kafka and post HTTP events, right?
That's a good idea.
Yeah.
So it's so symmetrical.
I mean,
Yes.
it seems like a good idea for symmetry, but I mean, it depends on people, if people are going to use it. I mean, or because where would this run? Like, if you have something that can consume from Kafka, do you really need to produce HTTP events? Like, I would probably just say, like, let's build it if and when someone needs it.
It's whether Marquez would want to incorporate it.
So in that, the thinking would be, if Egeria produces OpenLineage events and send them into Kafka for like their own integration to other systems, then Marquez would be interested to consume them, right? So it's kind of, I mean, it can be part of Marquez, but it sounds like, it's kind of this distribution is either you are in this picture, right? And people send HTTP events and it goes to one place, or you are in this picture and the event gets persisted into a Kafka topic, and then you can have multiple consumers and send to different places.
So I think that my point is, if you're thinking, oh, we need this in order to consume, these events from Kafka, then cool. That's a use case that my point is, I wouldn't do it simply for symmetry.
Just for love.
Yeah.
Oh, I see.
Agreed.
Yeah.
Someone wants to produce or wants to consume Kafka topics this way.
Yeah, that makes sense. I mean, I just mentioned the symmetry aspect because it kind of validates, kind of from an abstraction perspective, kind of like, okay, it makes sense. It sounds like the right place to put it. I think it's needed. Yes. Okay, that makes sense.
Yeah. Cool.
And from that regard to like, and also from the regard of simplicity, I think it would be great if the actual like plug into like Kafka or whatever the actual backend is that you're sending into, if we can build it as an abstraction so that a person can connect to those backends without having to go through the proxy. So like, we kind of talked a long time ago about having like maybe like a transport abstraction So rather than, just always having to send through HTTP, right, you could maybe have an underlying Kafka client that's actually doing the sending. And if you could use that same abstraction within the proxy backend, just so that way a person who wants to send to Kafka doesn't have to have a backend running. Because, as you kind of mentioned earlier, right, like it's another thing that you have to maintain operationally, right? So like if you're deploying to like a Kubernetes cluster, now you have to have like a sidecar or a separate service, or right. Whereas it might be nice if you just had the library that connected directly to Kafka. And then because I think that once you've built this transport abstraction, you open it up for lots of other use cases for people to build their own thing, right? So not everybody wants to send to Kafka. Some people want to send to PubSub. I don't think that we want to maintain the PubSub connector, the Kafka connector, the SQS connector, the RabbitMQ connector, right? Like, and I think that's kind of maybe what Ryan was alluding to, is that this can kind of explode in scope, and especially if we want to keep it symmetric by building the producers and the consumers for every single one of these transport technologies. Whereas if we have a reasonable abstraction layer, it allows people to build their own connectors. We don't have to maintain it. We just really have to maintain the abstraction and the one or two concrete implementations that are really relevant to us.
It's useful to have it. The downside is that the engine then has to be much more aware of the configuration for the producer is much more complex, because it has to, at the moment it's just very simple. It's an HTTP endpoint. That's all it needs to know. Whereas if it could be Kafka, then you've got the different servers that you need to connect to the bootstrap servers, and suddenly the configuration is now 10 different properties, and that's just for Kafka. Whereas if you have if you always have an endpoint, that's all the producer needs to know. And then the proxy backend, there might be multiple proxy backends, and it's that would be my only question, really.
I mean, yeah, I think that, like, yeah, if you're choosing a non-default like kind of transport mechanism, then that transport mechanism might have its own configuration, and we can figure out what's the right mechanism for managing configuration. Right now, I think everything is done through environment variables, but we can have a properties file or a JSON file or something like that where we start managing configuration, and then if we have a configuration mechanism that we can just kind of pass around, the Kafka library can look in that configuration for its Kafka specific configuration, but it doesn't. But the outer OpenLineage client doesn't necessarily have to be aware of the Kafka specifics.
Well, how does that work? So you have a client code. At some point, it's got to go across the transport abstraction. So how does it find its concrete implementation?
I would say this looks a lot like SLF4j or Log4j, or existing frameworks like that. You can plug in a Log4j appender quite easily using properties and an API there. So I think that's an area where we know that there are implementations that work exactly like we need to, and we can just copy what they do.
Yeah, I would open a separate ticket for that. I think this is a conversation that we can have independently, and that would be, that way we can have at the same time make progress on the proxy backend and have the conversation how we can send multiple things. It is true that maybe interface we want to implement is send this text blob somewhere. So it's a very simple one. Okay, that's cool. So we have 17 minutes left. So I think we have a good progress on this, and I think we have an agreement on following through with what you've been doing, Mandy. So there's consensus. So I'll make a to-do to kind of capture that discussion in a ticket. If everybody's okay, let's move to the next topic, which was the Iceberg requirements. And Ryan, what you were wanted to talk about.
All right. Thanks, everyone. Let me. Is it all right if I share my screen? Because I've got a little bit of background information to go over.
Good.
Can I not share a specific window?
Yeah, the first two top left should be your screens, and then everything else is the windows.
Yeah, I'm only seeing desktop and whiteboard. So awesome. I'll just do portion of screen and we'll see if we can do that. Can you guys see that?
Yes.
Okay, I'm just gonna drag it over here.
Oh, yeah.
Wow,
Zoomed in. Yeah.
All right. So this is, so Iceberg is a table format. You can think of it as at-rest storage on top of S3 or ADLS or Google, just basically cloud storage. So Iceberg is both a specification for interacting with everything in S3, and it is also a library that implements that. So we're working on a Python version right now. Most people just use the Java version. So we want to expose Iceberg through OpenLineage, Iceberg information. So what I want to give everyone some background on is basically what Iceberg looks like, the metadata structure, and then talk through like some of the things that I think we would want to log, and then figure out how to do that. All right. So what I have here is the basic Iceberg metadata tree. Iceberg has a specific sort of tree where we have data files. These are usually Parquet all the way on the right. We have three types of metadata files. One are manifests that track individual data files as well as metrics about each data file. We have manifest lists that do that same thing for manifests. And then we have a root metadata file that is basically all information that we're keeping about a table at some time. This means that the Hive metastore, or whatever you're using for a metastore to map some name like iceberg.table to a root metadata file, basically all it does is act as a pointer. So the most basic Iceberg table is a pointer to a JSON file, and that JSON file contains everything about the table: the schema, how it's partitioned, the table properties, history of what version was current at what time, as well as a list of snapshots. Now, a snapshot is a complete version of the table at any given time, and that's made up of the rest of the tree. So let's take a look at maybe a second version. So this is what, if I were to add two files to an Iceberg table, this is what it would look like. I have two data files on the right. I wrote those into a manifest that tracks data files, and then I added that manifest to a manifest list that represents snapshot S1. I have all of that in this new JSON file, and I atomically swapped V1 for V2, and now that is all of the information about my table. So the rest of the metadata tree, we have manifest list, which tracks what manifests are actually in my table. And it has things like partition ranges so that we can really effectively navigate through this table structure as a tree, so that we don't have to read everything all the time, which is actually very important for Lineage. Each manifest, like I said, tracks data files. It has partition and column ranges so that we can, again, select the data files that we need without having to actually go read all of them in the table. All right, so if we were to add another file you can see how the metadata changes on this slide. So we added c.parquet, we added another manifest to the table. So now we have two manifests, one tracking A and B, one tracking C, and then our snapshot 2 simply adds that new manifest to the list of manifests that make up our table state. So you can see all these arrows, we reuse every version of the table all the time. So my new JSON file tracks both snapshot 1 and snapshot 2, two different versions of the table. M1, our manifest with A and B in it, is in both versions of the table. However, snapshot 2 adds an additional manifest that tracks c.parquet. So this is sort of a way of reusing the tree of metadata and data files over time.
So Ryan, so that means the root version file tracks all the previous versions that you want to keep. Exactly, yes. And then we occasionally age those off. And when we age them off, all the references that are no longer in the tree, we go clean those up. So what we end up doing is the metadata root file has like 3 days of versions in it across many different manifests and data files. And then that tree structure keeps changing over time. We can also do things like compact manifests. We can rewrite them and group differently so that our tree structure is more effective for job planning and things like that. So that's what Iceberg does and sort of how it structures the data within your table. This provides atomic operations to update the contents because you can basically rewrite this tree structure in whatever way you want, add that as a new snapshot. That new snapshot gets written into table metadata, and we atomically swap V3 for V4 or something like that. Iceberg also provides, because it's a library, helper utilities for scanning the data that take predicates and then search through different portions of this tree, so that we don't have to read the entire thing all the time. So for the purposes of, or for the purpose of OpenLineage, here we go. This is my notes file. Let me expand this a bit. Iceberg actually provides already notifications at certain points in execution. So when you scan a table, it will currently say, hey, I'm reading table iceberg.table, whatever it was called, what snapshot or version of the table was used, what filters there were, what columns were projected, and things like that. This basically gets sent off into nothing because we have no registered listeners at this point, like we did at Netflix, but I don't think anyone else does. But this is how we plan on plugging into OpenLineage. We also want to start adding metrics to this information. So we want to add scan metrics. So how many manifest files did we actually read in order to plan what data files you need for a particular query, right? How many delete manifests were there? Because we have both data and delete manifests. It makes the tree a little more complicated than what I showed, but that's how we track delete files. How long did each manifest take to read and scan through? How long did the total job planning take? That should be planning. And how many files were per second, things like that. So that's at scan time, we want to know all those stats about basically how efficient was our tree structure in planning this query, right? In addition to what we already know, which is, what was filtered and what columns did we need. Next, we also have commit level metrics. So when I create a new snapshot, what we need to do is say like when the snapshot was created, what the snapshot ID was, what columns were written, what partitions were modified or appended to, and that basic idea goes all the way down into metrics. So how many manifests did we rewrite? Basically replace them with something where I removed a file and added a new
basically filtered out the files in a manifest. How many did we create brand new? How many data files were added or removed? Delete files were added or removed? And then like how many bytes were all of those things? You know, this gives us a lot of fine-grained information about, you know, maybe the average size of the data files that were written was 5K. And so we can see that we need to go back and go rewrite that data because it's just strewn across several small or, you know, tiny files. Also, Iceberg will retry commits if there's a conflict. So how many times did the committer need to retry? How long did each attempt take after the first? How long did the first take? You know, for each retry, what did we have to rewrite? Things like that. And then once we create that actual commit, we want information about it. So how many rows are now in the data set? How many files are in the data set in different categories and things like that. So I've been taking a look at the OpenLineage stuff, and I think it would really help me to talk through, like, you know, where does all of this stuff live? Obviously, like, these are probably data set facets for things like this information. So how many rows are in my data set? How many data files are in my data set? Things like that. But when do we actually emit that event? Do I emit it at commit time? You know, like it's a little unclear to me when we emit data set events. Everything else is pretty much tied to a run. So I might have multiple scan facets where I say, you know, these are the filters that I used, and then this is all of the stats on how I actually did planning this scan. And then the same thing on the commit side. So if this scan actually committed data to a table, then I want to know, you know, a little bit of information, quite a bit of information here. And we track all of this already. So how many data files were created, how many manifests were created, like all of that we already track. We just need to collect it and send it somewhere. So, you know, what does that look like?
I wonder if one of the first questions is, what is the subject of the event? Is the subject the processing that Iceberg is doing, or is it the calling process that's requesting data? Because I could see that it would make a lot more sense if Iceberg appears to be a sub-process of the calling, say it's being used by, I don't know, a Spark job or something, then the events are coming out, assuming it's a sub-process of something, because these are all, there is a thing and it's operating and doing these things. But what is the thing?
So the thing is some run of a job. We don't have the context for that here, right? So Iceberg just knows someone planned a scan on this table. I need to attach that somehow, and this is where
so you see these as facets to an external process's lineage, rather than it being a sub-process, the Iceberg being a sub-process of the calling process.
Yeah, Iceberg doesn't have any information to tie these events together. So if you run a select SQL query, that might hit 5 different tables, and we'll get lineage events for 5 different tables, but we need to tie those together in the context of a SQL query.
Yeah.
Similarly, if we run like a merge into query and end up creating a new version of the table, we need to know information about what we read from that table, what we read to merge into the table, and then what we actually wrote back to the table. You know, those sorts of things. And this is enriching the job that was that merge into query with the information about the data that was actually created. So in terms of lineage, right, what this gives us, say we're going for this merge into situation, maybe it doesn't really matter how much data I read from the target table. What matters is how many rows did I read from the source table to add to the target table? And then how many rows actually increased, how many rows did the target table increase by? That's going to tell you if the target table got 0 new rows, right? But the source table had 100,000 rows, then like something's going on. Maybe you're getting duplicates. If the source table had 0 rows to add and we added 0 rows to the target table, then it's upstream of this job, right? Like, so that information tells us different things about what might be going wrong in a given pipeline. So we really do need to tie these things to runs.
Sorry, and maybe I missed this, but who is it that's sending the notifications? Is this the library that runs on the client, or is this like another service somewhere else?
So Iceberg itself, the library, has a notification mechanism. Okay. So what we're probably going to do is create a OpenLineage optional consumer for those notification events. That way you can send, we actually send all scans to a table, or we did at Netflix, right? So that way we can tell, pretty directly what's going on. But we also want this lineage information to tie that together. And we'd probably just use OpenLineage if we could get all of the lineage, the rich lineage information, and not just the scan notifications.
So I think like probably the best way to do this. So for example, if we take the context of the Spark integration, like to have those tied together, because the Spark integration will give you the context of what's the job, what's the run, and tying the inputs and outputs together. Yeah. And then if we can, like, for example, we can start with prototyping that, having the Spark integration at the Iceberg listener to get this metadata and attach it to the right input and output. So in the OpenLineage model, you have dataset facet that are about the dataset itself. Like if you have absolute number of rows, how many rows are in this dataset now, it's a dataset facet. But if it's something about the scan or about the writing aspect, then you have also inputs and output facet, right? And those are related to that particular run, right? Like in the model, you have the job level metadata, like what is the current version of the job, and that's something that can be the same from one run to the other. You put it in the job facet, and when you have run level metadata, like for example the physical plan that we save, you put it as a run facet. So in the data set, similarly, you have the data set facet for things that are recurring, like the schema of the data set at the time of run, and you have like run facets, input facet or output facet that are related to the scan or the production of the data. And so that's where it would be. So I think we should start looking at how, I think we talked a little bit about this, and it's similar to SLF4J or like logging system that have like a context, right? You attach the context, what's the thread name, or like other contexts like that. And then when something logs, they don't necessarily know what part of the thing they are, but whatever metadata they send, it's part of that context. So from the Iceberg perspective, Iceberg would say, hey, I'm doing this scan. And because it's in the context of the integration, you will know what run ID it is, and it gets attached. And to your question about when do we send those events, I think right now the Spark integration sends an event at the beginning and another event at the end. But the spec allows to have intermediary events, right? If it's a need for you to say, hey, we want to know about the scan when it happens, not when the particular job finishes, then we should. And in the Spark case, each OpenLineage job is each action, right? Like if you have a Spark job that does multiple things in it, so if it's a Spark SQL, it's probably just one thing. But if you have a Scala or Python that does multiple operation, each of them will have their own start and end, right? And they're all connected to the parent logical Spark job, right? Like people may run one process, but it does multiple jobs inside of it because each action or command is going to be one thing.
So I've actually got to run since it's already 10, but what I just wanted to, hopefully throw that out there so people can start thinking about this use case and help us sort of map it to OpenLineage. I'm glad that there isn't like a client or logger implementation yet, so that we can kind of consider this as maybe one of the early things that we want to do along with Spark, right?
Yeah, could you add all your notes? So so you took the effort of listing all the things that are available that you want to post. Can you add that to the Iceberg issue in OpenLineage so we kind of?
Yeah, we'll do. I got to run though, so I'll see you guys.
See you later. Yes.
Bye.
Okay, and so, okay, let me get back. So we're a bit out of time.
Okay, so
I think we
just
last.
us.
Everybody else has dropped off.
So I'm just going to wrap up. Sorry, a little bit over, but this is nice. Let me just wrap the meeting. So we did, I'll follow up on Slack regarding the Beam integration that someone asked about. I think we have a couple of actions on opening tickets to track those things. And anyway, we were done. So the last thing is just a reminder of where the roadmap and the prioritization of tickets work. And we were opening on open discussion, but I think we did quite a bit on the.
I wanted to ask some questions.
To
Ryan,
whom?
but to Ryan.
Oh, yeah. So please follow up. Let me see. I think the best way is probably to ask question. So let him have his notes in the ticket. So I'll follow up with him to make sure the notes he was showing get in the right issue. And then I think the best place to follow up is there.
One question may be conceptual, right? About this type of situations that we are now dealing with. So we have, let's say, Spark or Airflow or anything like orchestrator, like which emits events, and then we have underlying like Iceberg source or Dbt or something like that that also wants to be friendly to OpenLineage, right? Maybe not in this case necessarily emit events themselves, but we have somehow tied those things up, right?
Yes.
Have some, at least, I don't know, knowledge how we want to deal with those situations.
So the current mechanism for the nesting of those things is this notion of parent run, right? So you can say, like, for example, in Airflow, you may have a run for the DAG, and then a run for the task, and then a run for the thing that the task starts. So that this notion of parent run, and that's the easy ways to connect those by saying, well, here's the ID of the thing that triggered that, right? And they're kind of all nested. So that's the current mechanism. The other mechanism is in the context, like for Iceberg, for example, it's not necessarily a sub run, right? The scan itself is not a sub run, but it's adding metadata. It's in the same process, right? Iceberg is in the same Spark process. So it can just pass the metadata and it gets added by the Spark integration, for example.
Yeah, I was just thinking you can modify multiple things there and both modeling that. That's never mind. Like Dbt is I think poster child for this type of situations because we have Airflow runs, then you have each one of the tasks can run Dbt process, which can also run multiple jobs itself.
Yeah, that's a good point, right? So for Dbt, for example, so in the Airflow integration, we collect metadata about the BigQuery metadata, for example, that is returned by BigQuery specifically. And currently it's not collected in Dbt, so we have to figure out, I think in Dbt, there are mechanisms for each connector to add, there's a dictionary that they can add extra metadata. So it can be this way that each connector provides more metadata, similar to what Iceberg wants to do in Spark. But in Dbt, each connector could provide more metadata through this mechanism. And then at the top level in the Dbt integration, they can be added. That's like one relatively simple way to do this. Cool, but yeah, you know, if there's something you think we should discuss more, like feel free to open a proposal ticket on the OpenLineage, and we can use that as support for like deeper conversation. I think like we're lacking some documentation to talk about the parent run mechanism as well. It's mentioned in the spec, but it doesn't really go in the details of that use case you're talking about.
Yeah, just like also thinking which part of the metadata should go where, right? If we should propagate something to the parent run, or because I can think of situations where we get deeply.
I mean, so my thinking here is that
pieces, right?
I kind of feel like the data set sources should probably be focused. What's that? Oh,
it's fine. It's just
I'm not sure if you hear that because my cat is whining right now.
That's fine. We hear it, but it's just cute. It's not destructive.
I didn't hear it at all. So, but yeah, no, I mean, I kind of feel like let's let the data set sources be really focused on the information that they provide. And I feel like the responsibility of tying that information back to the run should be in the orchestrator, right? Because it's going to vary depending on the context. So a Beam orchestrator is going to be very different from a Spark orchestrator, which is going to be very different from an Airflow thing, right? And so, you know, if the Iceberg can really just send the events, and if they can, you know, do the translation from those events to the OpenLineage model, like a data set, input data set, run facets, right? And really just focus on that, then the orchestrator, each orchestrator can build its own thing for collecting those events and adding them to the runs. I already have, you know, some ideas on how we could do it in the Spark thing. It's not going to make sense in Beam, right? So I think the Beam thing should do its own thing. But the conversion from Iceberg events to dataset or Iceberg events to facets, that's going to be common. And I feel like, you know, we could just like keep that embedded in the Iceberg thing.
Yeah, I think ideally Iceberg like just emits facets, and like the higher level context knows how to attach them to the right place, right? Can say, hey, here's a facet for that data set input. And that way we don't have to duplicate like conversion of those things. Like Iceberg start depending on OpenLineage as like exposing those facets as standard metadata, and then it gets attached to the right place. Cool. So thank you everyone for joining. I think this was a great meeting today, and I'll be posting my notes, and feel free also to comment on those. Have a great day or evening, and see you next time. Bye-bye.
Bye.
Yeah. Bye, everyone.
Bye.